Question 8a, if 3 minus s, 6, 7 minus 5s are consecutive terms of a geometric progression GP with constant ratio or common ratio arrow greater than 0, find the Roman figure 1 values of s, Roman figure 2 constant ratio. Solution: in geometric progression, you should note that the common ratio is obtained by dividing second term by first term, and that is always equal to third term over second term, and that is always equal to fourth term over third term, and so on. Because we have 3 terms in the given GP, let us consider these 2. Second term is 6 over first term, equal to third term is 7 minus 5s over second term 6. If you cross multiply, you have this result, that is 6 times 6, 36, equal to the product of these 2 terms. If you expand the right hand side, you have this result. So this term here simply means the result is a quadratic equation. For us to factorize or use any other method, you ensure that one of the sides is 0. So let's transfer 36 to the right hand side. It becomes minus 36 plus the rest terms in the right hand side. Note these 2 things, they are common. If you add them, you have minus 22s. We usually follow order of the highest power of the letter. So we have 5s squared minus 22s minus 15 equal to 0. If you add the 2 constants together, you have minus 15. For us to factorize, if you compare the resulting equation with the general quadratic equation, you will agree with me that a is equal to 5, coefficient of s squared. B is equal to minus 22, coefficient of s. C is equal to minus 15, the constant term. Whenever a is not equal to 5, we always get AC, and AC is 5 times minus 15, and that is minus 75. By this, your attention has shifted from C equal to minus 15 to AC equal to minus 75. You look for 2 factors of 75 whose sum is minus 22 and the product is minus 75. Such factors are minus 25 plus 3 in S. You always express the given factors in S and use them to replace the middle term or second term in this form. The purpose is to get 4 terms so that you factorize by grouping. The first 2 terms, first group, the last 2 terms, second group, you equate to 0. From the first group, 5s is common. If you factor out 5s, you are left with s minus 5, plus in the second group, 3 is common. If you factor out 3, you are left with s minus 5 equal to 0. Clearly, s minus 5 is common. If you factor out s minus 5, you are left with 5s and plus 3 that we combine to form the other bracket, and you equate to 0. You equate each factor to 0 in this form. If you transfer the respective constant terms. You have s equal to 5 or 5s equal to minus 3. If you divide the second linear equation by 5, divide through by 5, you have s equal to minus 3 over 5. Writing the smaller number first, you have s equal to minus 3 over 5 or 5. So we have two values for s. Roman figure 2 of question 8a, you are asked to find the constant ratio. You can obtain it using this or this. Any part you choose to use, you have the same result. So let's take the first part. When s is equal to 5, you replace s with 5 in the first part, and you have 6 over minus 2, and that is minus 3. To be very sure, if you take the second part and use s equal to 5, surely you have the same minus 3. So this is the second part. You replace s with 5 in this form. You multiply, you have this, subtract, you have minus 18 over 6, and that is minus 3. If you also use the second value of s, minus 3 over 5, you will have the same constant ratio using any of the two parts. Question 8b, you have this diagram. In the diagram, AB is equal to 3, BC is equal to 4, that is in centimeters, CD is equal to 6 cm, and DA is equal to 7 cm. Calculate angle ADC correct to the nearest degree. This is angle ADC. Because the figure is a trapezoid, we need to join this side together, so that once you get AC, considering triangle ABC, you can get angle D by cosine rule. Let us see to that. Angle ADC can be obtained using cosine rule, but AC is needed first. Which can be obtained considering triangle ABC by using Pythagoras rule, because this triangle is a right angle triangle. AC happens to be the hypotenuse. So you have AC squared equal to AB squared plus BC squared. You have it in this form, and that is this, and you have 25. To get AC, take the square root of both sides. AC is equal to root 25, and that is 5 cm. Considering triangle ADC, you state the cosine rule in this form, that is AC. You start with AC because you are looking for the angle that is facing AC. So AC squared equal to AD squared plus DC squared minus 2 times the product of AD BC, then cos D. That is where you have angle ADC. So we are interested in the angle now. So let's make this part the subject. If you transfer it to the left, it becomes positive. You transfer this one in, it becomes negative. Divide both sides by this coefficient. You have cos D equal to this. You know, the cosine rule is used in two versions. When all the sides are given to you, you also use the cosine rule. and that is what I'm doing right now. So you replace the various sides and you have this. If you simplify, you get this. You add and subtract, you get 60/84. When you divide, you have 0.743. To get angle D, which is angle ADC, you take the inverse of cosine of this value, and that is what you have here. If you share the inverse of cosine, you have 44.4141 degrees. To the nearest degree, you have 44 degrees. Pythagoras simplified maths. If you are watching and viewing from YouTube, don't forget to subscribe, like and share PSM videos. If you are watching and viewing from Facebook, follow and like the page. Also share PSM videos.